I think that's doing it. Okay, so welcome to today's lesson. We are going to look at neutralization, naming salts, and all those bits that go on from acids and alkalis. I haven't put any polls in, but that's because I'm going to annoy Mr. Collins by asking you to type in the Q&A any answers when I ask you questions. So that's my plan of action to keep you all going today. I'd also like to apologise because I didn't manage to put any cats in today. So sorry for the lack of cats. I'll try and do some random meowing as we go through to make up for that. So this week, obviously, you've got the webinar and then rewatching it. There is the Google quiz. And then the big question, what I've done is put like a summary sheet together. And for that, you can either print it off and fill it in. You can make flashcards on the individual little boxes. Or if you want to work on the computer, you can fill in the slide sheets that come with it. And that's why I've also put flashcards, because it's useful to get in that habit of making your revision resources now so that you've got them later on and you don't end up panicking that you haven't got them. Has anyone got any questions before I start?
Second, but someone says, I can't see other people's Q&As. That's because there aren't any at the minute. I've dismissed them because we've resolved them. So I'm going to dismiss that. There we go. Freya says, always lovely to be wished good morning by you on a Monday. It doesn't appear to be any questions, Thomas, so let's get going. Okay,
awesome. So first thing I just wanted to remind you of is the pH scale, because we are talking about acids and alkalis and the reactions. And just to be very, very clear, when you're talking about your colours, neutral is always going to be the one that's green. Anything like milk here looks green, but I would call it greeny yellow. And then coffee and tomato I would call yellow, going down into oranges and then pink reds. So just to make sure, green should only ever be given as 7. And then the other colours you can sort of put greeny blue, green yellow, but don't put green for pH 6 because you wouldn't get a mark. So I just wanted to be nice and clear on that, and hopefully we're all happy with the idea. Acids that are strong are generally going to be red, and then alkalis are going to be like a dark purple. Okay, that is just me doing a quick recap on last week. Okay, so this is a really important bit of information that you are going to need and you're going to be using today. So the 3 main acids that you will need to learn are hydrochloric acid, which is HCl, sulfuric acid, which is H2SO4, and nitric acid, which is HNO3. And my first question to the Q&A is, what do they all have in common? And I can see people raising their hands. Unfortunately, I can't do much with that. So if you know the answer, do type it in the Q&A box to Mr. Collins. What we got, sir?
Decent answers.
Oh. So I heard decent answers. So has everyone said they're all acids? Oh, yeah, I can see some of you. Yeah, you've all got it. I've just gone on to that to have a look. You're all right about hydrogen. Some of you have put little H+. Just as a little note from me, never put your elements as little letters unless it's big N, little a. It should always be capital letter. You can lose marks for that one. So just make sure you're putting capital H. But well done. So yes, if they're acids, they all have H+. Now my next slide, which I'm going to show you, has got some acids and some alkalis on. And the reason I'm showing you this with their formula is because you should hopefully be able to, and I mean, I'm not going to move them around, be able to tell me where they go. So I am going to ask you in the Q&A box to tell me whether or not, and I'm going to pick them at random, you see, KOH is an acid or a base. So that was KOH. What would that be? And you might get a bit confused because we just said that acids have H's in them. So I'm hoping you won't. What we got?
Give them a bit more time. One person said, do we have to learn those 3 acids from memory? Yes, you do.
You do.
Okay.
But what I will say is, 1, make a flashcard and on them, and 2, we cover them a lot. So through all your teaching, the acids we will always talk about are hydrochloric acid, sulfuric acid, and nitric acid, to the point where you'll probably get bored of hearing them. Would you agree, sir?
I'd say so. So 2 people said acid, everybody else said base for KOH.
Excellent. So those of you who said base, you are spot on, because it's the OH minus, and I know these don't have charges, but it's the OH that makes it the base. I'm going to pick another one just to check how we're going, which is going to be CH3CO2H. What do we reckon? Is that an acid or is that a base? CH3CO2H.
Okay, more mixed this time. Again, so far we've got 2 acids, 3, 4 acids, 1, 2, 3, 4, 5 bases.
Okay, so majority is correct there in that it is a, no, majority it's, what am I doing? See, I'm muddling myself now. So what I would say is your tip is the OH have to be sat next to each other. So I can see that it's got CO2H, but that means that that CO2 is separate from that H. Okay, so that would make it what? If you've put an answer, I'm going to ask you to do it again. So the H is separate from that O because it's joined with the carbon. So what would that make it?
So most people now getting it right.
Yeah. Okay, awesome. So those of you, go on, sir.
One person asks, so is it a base if the O and the H are next to each other? Yes, yes, they are.
Yeah.
Now, you might say it looks a bit like there, the CO2 is next. You need an OH separately. If that was a base, the way we would write it out is CH3COOH. And we would write that OH separately, even if there were other oxygens around in that molecule.
Okay, excellent. And I'm going to pick one more, which just because it looks slightly different, which is the calcium hydroxide. So Ca bracket OH bracket 2.
So is that an acid or a base?
Sorry, I forgot the question bit there, didn't I, sir?
Yeah. Well, there we go. People understood.
Excellent. Awesome. So that's our basic bit. So all acids are going to have the H plus, and all bases are going to have the OH minus. So excellent. And I will warn you, I might bounce around a bit because as I do typically in lessons, I bounce. So
chat currently is all about that base.
Yeah, I'm not singing it. You do. So you will be expected to name the salts made when these chemicals react. So when these acids react with an oxide or a metal, you'll be expected to know the name of the salt made. But I actually think this is one of those bits that's quite easy once you get your head around it. And again, it's going to be a flashcard thing. I'm hoping you can all see all 3 there. So hydrochloric acid always makes chlorides. Okay, and the clue there is going to be you're looking for chloric to make a chloride. Okay, and then a sulfuric acid will always make a sulfate, and then a nitric acid will always make a nitrate. So the names are very similar. So in your reactants, you would have your hydrochloric acid or your sulfuric acid, and in your products, once you've reacted it with what you're doing, the salts that you get named will be chloride, sulfate, nitrate. Has anyone got any questions on this? I've got numerous slides sort of explaining it, but this is one of those basic bits, and this is one of those bits that I'd say flashcard if you are going to make flashcards.
Just so it's really clear. Okay, so someone's asking, what does it react with to make a salt, though?
So they can react with various things. So they can react with bases. They can react with your alkalis. And if you remember, an alkali is a base that dissolves. They can also react with metals. And I will be going through the different types of reactions in this lesson. But in any of those types, or a carbonate, that's the other one. But in any of those types of reactions, it produces the same thing. So this is a general rule for any of these reactions. I hope that's helped clear it up a bit, and why I haven't talked about any of the reactions yet, because this is just a general rule.
Yep, I think we'll move on and we can always come back if there are more questions later.
I think it'll come up again anyway. So as I said, I'm bouncing. Okay, so when we make salts, one of the reactions that you can get is the acid plus your alkali, and then that would make your salt plus water. Okay, and if you think back to what's an acid and what's an alkali, an acid is a H plus ion and an alkali is an OH minus ion. What's water? And feel free to type it in if you can. So I want to see in formula format, what is water?
Yep, and we're starting to get lots of people knowing it.
Awesome.
Just again, bear in mind what Miss said earlier about capital letters. So when you're doing H for hydrogen, it should be capital H. When you're doing O for oxygen, it should be capital O. Water is cold. Only cold water is cold. Hot water is hot.
Yeah. Okay, and just to check, I'm not going to ask you to put the name in front of it, but what type of salt would be produced now that I've put hydrochloric acid plus sodium hydroxide on there? What type of salt?
So thinking back to that rule that Miss gave you on the previous slide.
Rule. Hydrochloric.
Well done, Matilda, first in there.
Awesome. Well done.
Some people have gone the next step and have given the full name of the salt, not just the given both the positive and the negative ion.
So excellent. And those of you who've
got an Amira.
I'm trying to see if I've got it. I don't think I did have it on here. The full name would have been sodium chloride plus water. So the metal, which you can use your periodic table to find if you're unsure, but generally is the first bit of your alkali or your base, always is, it just goes in front of the salt name. So sodium chloride. And then because we know we've got the hydroxide and the hydro, that makes your water. Okay, the next one that we've got is acid plus base. And remember, your base doesn't dissolve. So similar reaction, salt plus water. And an example of a base, which you'll need to be aware of, is your oxides. Okay, and then we've got hydrochloric acid plus copper oxide. And who can tell me the name of the salt, the full name this time, because I'm mean. And I did just explain it. So what's the metal in that oxide and what would it go in front of?
Oh, yeah, very good. Somebody's given the full one.
Nice.
Full name and the other product of the reaction. So good job, anonymous attendee.
I can see we've got less responses on this one.
I'd say fewer, but yes.
Okay, so on this one, you should have spotted that the metal is copper and the acid is the same one. So it's hydrochloric acid. So that would become copper chloride plus water. Okay, and hopefully we're getting that. I'm going to have more examples of these for you guys to practice, so do not worry too much. Okay, any questions on this slide before I move on? And I know I'm asking that a lot, it's just I don't want to make sure you're all happy and you're all good before I bounce it to the next bit. I think you're all good. Okay, so this is put in as...
sorry, Miss, there was one question. What makes a salt and not a metal? And maybe you want to talk about the difference between salt in chemistry and salt in cooking. Okay,
well, salt in cooking is sodium chloride, which is an example of a chemical salt. In fact, we've got it on the board now. Hydrochloric acid plus sodium hydroxide makes sodium chloride plus water. So that makes our table salt and water. I would never recommend eating one that you've made in a lab, by the way. So a salt is purely going to be a metal joined with a, how would you describe it, sir? The chloride bits.
I would say it is a neutral compound, so it contains neither hydrogen nor hydroxide. So it's a neutral compound that's made in a reaction.
There you go. Thank you, sir. I had a brain wipe.
things that acid reacts with. We talked about alkalis, we talked about bases.
And my next slide is going to summarize them all for you, because I thought I'd put a lovely one together for you. So
sorry, miss, there's one more question just come in. When you mix an acid and an alkali, you always create water. Yes, that's right. Remember, you've got the H+ ion in the acid and the OH- ion in the alkali. So H, HO, two H's and an O, H2O, that's water.
Yeah. And this is basically all the rules for all this naming stuff. So you can see I've got on top left, my acids are H+, and my alkalis are OH-, and they're called hydroxides. My base is an insoluble alkali and will typically be a metal oxide, and that's where you get the oxygens from. You can then see top right, we've got the word neutralization, and we've got acid plus alkali or base makes the water. And you can see I've broken up the ions there to make up the water. And neutralization reactions will happen anytime we add an acid and an alkali to make our water. That's what neutralization is. We're neutralizing it to that pH 7 green. And then the different rules for making the salts and what you get, and I'm going to run through these a bit more. So if we put a metal with an acid, any metal, you will always get your salt and you get hydrogen. So that one's slightly different in that you get hydrogen. And then we've got our metal base, which I've just talked about, which would be your oxide idea, plus your acid, that would make salt and water. Then we've got our metal hydroxide, typically your alkali, that also makes salt and water. And then this one, the last one, is the one which has an extra bit, but I always remember by looking at what I start with. So you've got a metal carbonate and you get your salt and your water, but because of that carbon, you get carbon dioxide. Okay, and again, I've put the naming salts rule on there. So you put the name of the metal first and then the name of the acid afterwards. So chloride, nitrate, sulfate. I am aware this is a lot of information on this slide, but this is the summary slide. I am going to talk through these reactions a little bit more. But does anyone have any questions at this point on any of this? Because I just gave you lots of information.
So somebody's asked about fully neutralizing, as in getting back, I think, to pH 7. And they've suggested a reaction between something that's pH 14 and something that's pH 4, and saying that the 4 might not, the 4 is only a weak acid, whereas 14 is a strong alkali. I'm kind of reading into the question here and saying, so if I mixed 4 with 14, would it get back to 7? And the answer to that is, it really depends. It depends on the concentration of those two acids. If you had a very dilute pH 14, but a very concentrated pH 4, then it may be that actually when you mix them together, you end up with something that's pH 5 or pH 6. It might not even get back to, it might not even be an alkali at all. So it's very difficult to say. Okay, right, I understand. So they've just said, but water is pH 7. So what we're looking at here is one molecule of acid will react with one molecule of alkali, let's say, and that will make one molecule of salt and one molecule of water. There might be millions more, billions more molecules of acid floating around which don't take part in the reaction at all. So the reason that we are neutralizing it is we're bringing the pH back towards 7. We are making that ratio of hydrogens to hydroxides closer to 1:1 by doing this chemical reaction. Now, it might not get there, or it might go past it from acid to alkali or alkali to acid, depending. But the idea of neutralization is moving it towards neutral, taking an acid and moving it towards 7, taking an alkali and moving it towards 7. That's the idea of neutralization. You can get complete neutralization. We will be looking at that in more detail when we look at something called titration, but that is something for when we get back.
Thank you, sir. Oh, okay, I'm going to wiggle it on. So this is the metals with acid, and this should be a bit of a recap to when you were in year 7 or year 8. So when metals react with acid, there's a fizzing, which is bubbles. What are those bubbles?
I think at this point, Miss would like you to type it into the chat. Some of you already have.
What are the bubbles?
Good. Yep. Lots of you are paying attention. 4 of you so far.
And
Freya, which gas is it? So Freya has said gas releasing. You're absolutely right, Freya. It is a gas releasing. Which gas is it that's being produced, that's being released?
And bonus question now. How do we test for that gas?
Ooh. Have to pop your thinking caps on.
Very clever there, sir.
So some people saying oxygen being released.
Oh.
And some people saying carbon dioxide.
Okay.
So maybe if you want to go back a slide, Miss, and we'll just talk about
back a slide. So when we have a metal with an acid, so it could be magnesium plus acid, we get our salt plus hydrogen. Okay, because we can't get the carbon because we haven't got any carbonate when we've got a metal and an acid. We've got no carbon, and we can't get an oxygen because we can't get an oxygen because there's no oxygen there, because our acid is H plus, and then our metal would be sodium or magnesium, and there's no oxygen actually there. Okay, so hopefully that has cleared that up, sir.
Yeah, it's a really good example of a displacement reaction here. So remember your reactivity series: potassium, sodium, calcium, all that stuff at the top, all the way down. If you mix magnesium with hydrochloric acid, you can put hydrogen in that reactivity series of metals. Magnesium is more reactive than the hydrogen, so the hydrogen is displaced by that more reactive magnesium. So it's a good example of a displacement reaction. I think earlier Miss said it will work with any metal. That's nearly true. There are a few metals that are less reactive than hydrogen, specifically copper. Yeah, copper, silver, gold, platinum would be the ones you might come across. So it's nearly every metal will produce hydrogen.
And they got the test for it, sir?
Some of them did, yes. A few of them. Archie Smith and a couple of anonymous ones talking about the pop test. And that is to put a lit splint near the mouth of the test tube, and it will make a popping sound as the hydrogen reacts with the oxygen in the air to make water again.
Yep, it's the squeaky pop. Awesome. So this is it again, and I've done it. So reactions of acid and metal are only possible if they're more reactive than hydrogen in reactivity series, sir.
There we go. Yeah.
Acid plus metal, salt to hydrogen. Excuse my arrow being off. And we've covered how we test for it, so we're all good on that one. Okay, acids and bases, all about the base. Sorry, had to. It's a neutralization reaction, and we are often using the oxides, which are the insoluble bases, or hydroxides, which would be our alkalis, and these ones always produce your salt and water. And again, I apologize about my arrow being squiffy. So acid, which is aqueous, and bonus question, what does aqueous mean?
Into the chat.
Yeah, into chat. What does aqueous mean?
That brackets AQ. Well done, anonymous attendee. Margaret, good job. Kaya, you're nearly right. So Kaya said liquid. If it were a liquid, Miss, what would it look like?
If it was a liquid, it would have the letter for liquid, which is an L.
So the most common liquid that you come across in these equations is water.
Yeah, which
water
it with an L next to it.
So on the products there, the water should have little brackets with an L if you were indicating the state symbol of that water. But AQ, as a lot of you have said, is dissolved in water. An aqueous solution is one that's dissolved in water. That word agua in Spanish means water. So it's dissolved in water.
And S for solid and G for gas. Excellent. Okay, and this is your insoluble base practical thing. I'm not actually going to stay on this too much because you will do this in lesson, but essentially it's when you join an acid, a base with an acid, you get your salt plus water, and you will do these practicals when we get back. So I've just put that in to let you know we are thinking of these practicals and you will get to do them. Acid and carbonate, and who was listening earlier? Acid plus carbonate makes salt plus water and... question mark.
Good, well done, Margaret, and a couple of anonymous attendees. Yep, mostly right. Some people are saying carbon. It doesn't make carbon by itself. Now, something that Miss didn't show you is the chemical formula for a carbonate is CO3. Now, one of those 3 oxygens reacts with the hydrogen to make water because you've got H2O, so you need 1 oxygen for the water, and you've got 2 oxygens and a carbon left.
They got it.
A lot of people have got it.
Cool. Carbon dioxide. Okay, and then that gas will cause bubbling because it's a gas. And to recap you, if you are trying to detect carbon dioxide, you use lime water. And what happens to lime water if carbon dioxide is present? Oh, going back a bit here. What happens to lime water if carbon dioxide is present? Let's see if you can remember. Anything, sir?
I'm just giving them a moment to type their answers.
Awesome.
Some people saying it changes color. You're not wrong. But people like Margaret and Laurie and another autonomous attendee are giving better answers, saying it either goes cloudy or Margaret's. I really like Margaret's answer. It becomes milky white.
Lovely. Milky white or cloudy. Lovely. Well remembered, by the way, guys. Okay, so that is our carbonates. And again, as I said, there's lots of recap of these because I want to make sure you're getting the ideas of them. So acid plus alkali, salt and water. And your alkali is your soluble base, so you'll get your aqueous solution. Then we've got acid plus metal, salt plus hydrogen because there's no oxygen there. Our acid plus our metal oxide, these are going to be your bases, your insoluble ones, so you're solid with salt and water. And then lastly, your acid plus carbonate to make your salt, carbon dioxide and water. Okay, and again, that's just me recapping these equations. So, and I think I'll put them on twice because that's the sort of thing I do, so different ways. You know what I'm like. And I don't know why I've got this, but just to, I was probably going to ask the questions. So we've got base reacts, we'll get salt and water. What's this whole process called? We've mentioned it quite a bit, but I'm going to throw that question out. So we've got our base is our chemical that neutralizes an acid. When a base reacts with the acid, we form the neutral salt and water. What's the whole process called? In the chat box.
Yep. Tally's got it. Well done, Tally. And a few anonymous people, 3 anonymous people now have got it.
Awesome.
Fantastic.
So I'm going to jump it. It's neutralization. So well done, lovelies. And we've done the reaction, but can anyone remember the general equation to describe what happens when a metal oxide reacts with an acid? So what is the general equation for working it out? What happens when a metal oxide reacts with an acid? So it'd be acid plus metal oxide.
Word equation. Word equation.
Word equation. General equation. Sorry, my bad. Acid plus metal oxide form I know.
Some people are just putting the second bit.
Yeah, that's fine.
Fine. I've got an autonomous attendee. If you put your names in, guys, it means we can shout you out when you're getting it right, which is really good. So Margaret, fantastic Margaret, I see Margaret has got it right. Well done.
Awesome.
An interesting answer here.
Go on, sir.
Metal oxide plus acid equals acid oxide plus water. So that acid oxide, remember, acid is got the presence of hydrogen, and that hydrogen ends up in the water, and the oxide, that oxygen ends up in the water. So what you end up with instead is, as a different anonymous attendee has said, it makes salt, a chemical salt plus water. Yep. So these there's 4 of them that were on the slide Miss showed earlier, and it really is worth learning them, because so often in the exams, well done, Amira, so often in the exams, these ones here, yeah, they come up and
water on the bottom one going back.
You can get an easy mark just for knowing these, for writing them out, or for applying them, where they give you the name of the acid and the metal oxide and ask you to predict what's going to be made. And so that you'll have to remember that it makes a salt plus water, and then work out the name of the salt, which Miss talked about earlier.
Okay, and that question was this one here. So acid plus metal oxide, salt plus water. Okay, so I'm just going to click through again. Bear with me. Metal oxide plus acid, salt plus water. Okay, and then we've done squeaky pop, but I put this slide on. So calcium plus hydrochloride to do it at the top. So actually, I'm going to get you to do the top 2. We're not bothered with all 4, but answers in the chat. So calcium plus hydrochloric acid produces what? And zinc plus hydrochloric acid produces what? Into the chat box, numbers 1 and 2 only. We will give you time to type. And while you are doing that, I will go meow, 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 because I forgot to put cats in. Meow, 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 meow. Don't know what that was then. Meow, 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 meow. Meow, 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 meow. Meow, meow, meow. Meow, meow. I just realised I'm recording this, so now those are going to be a YouTube video of me going meow, meow, meow. Oh dear. Never mind, sir.
Okay, so interesting. Some people are making some mistakes here. So I would encourage you to look at the example in sort of the top of the slide, just below the green writing. There's an example there. Have a look at that. Lots of people are saying it's making water. If you look at that example, you'll notice water doesn't feature anywhere. So have a look again and resubmit your answers. If you put water in there, then have a look again. Now we're starting to get some right answers coming in. That's really good to see.
It is going to be a case with these of, unfortunately, learning the 4 reactions and what they make, which is why I would say flashcards on these 4 main reactions, maybe with an example of each one, and then how you name the salts from the acids. That would be a really key thing to go away and do, which is why I did put flashcards on the lists of to-dos. Because once you've got a metal plus an acid always makes a salt plus hydrogen, you've got it. It's in your head. It's the same as once you know the alkali and the base both make the salt plus water, you've got it. And then once you know that carbonate with the carbon makes carbon dioxide, you've got it. So it is just going to be a case of making sure you know which is which.
So there's a few people who are just putting the name of the salt. You've got to remember, it's not just the salt that gets made, something else gets made as well.
Yeah, so typically I think these would give you 2 marks in an exam. There'd be 1 mark for naming the salt, and then there'd be 1 mark for naming the other product. So it's worth trying to remember which ones are which. Well done, by the way, if you are naming the salts.
Yep, I'm sending lots of well done messages to people who are getting it right, just so you can see that I've seen that you've got it right. Something that's been asked earlier and been asked again now, could you put a list of everything to flashcard? Maybe if we could condense that down into a small document and upload that to the Google Classroom.
Yeah, so what I would recommend, I'm going to hit escape because it'll make it easier, is essentially, where is it? Way back here. This slide here would be what I would put on flashcards, and I would probably make 4 flashcards. So 1 with the acid alkali base bit, 1 with the neutralization reaction, 1 with the naming salts, and 1 with the soluble salt reactions. Or you could, yeah, but this slide here would be what I'd do, and I will make a copy of that in a bit and put it in separately as information for flashcards. Hopefully that's helped, guys. Okay, I'm going to go back. I'm going to talk through these because I've got some more examples for you to try. Oh, hello. I always forget to click you on. So the first one, you should have got calcium plus hydrochloric acid produces calcium chloride plus hydrogen. And then zinc chloride plus hydrogen, because these were metals with acids. And well done if you guys got that, and well done to those of you who went away and corrected the water back to the hydrogen. Okay, and I've got some more to try now, but I am a bit mean in that I have put different acids in. So I'm going to go through these very quickly. I'm sure Sir won't mind. So magnesium plus nitric acid produces, and I only want one word answer here, what does it produce? What is the name of that salt?
2 words, not 1.
Yeah, 2 words, unless you write salt, because you're being cheeky.
We want the name of the salt that gets made, and we're getting well done, Archie, well done, Margaret. Some anonymous people, well done. Yep, Tally, that's right.
Awesome.
No, never put question marks in your answers.
No.
Never do that.
Or I don't know question mark after an answer, because it
Yeah.
makes the examiner think they don't know what they were doing and they may not mark it, even though you got it right. So
Dante, have a look at the acid again. It's not hydrochloric acid this time. So have a think about that. See if you can resubmit, having thought about the name of the acid.
So magnesium plus nitric acid makes... How are we doing, sir?
Yep, lots of right answers. I'm sending them messages telling them they got it right if they've got it right.
Okay, so I'm going to go through that one. So it's magnesium plus nitric acid makes magnesium nitrate plus hydrogen. And next one then, zinc plus sulfuric acid produces, and we want 3 words here. Yep, 3 words here. 2 together and 1 separate. Zinc plus sulfuric acid produces.
Okay, lots of right answers coming in.
Woohoo! So that one.
Laurie, have a look at the acid again, Laurie. Some people just giving the name of the salt. Remember, we've got to give the name of the salt and the other part that's made the other product. So Zach, have a think about that.
So zinc plus sulfuric acid produces.
Laurie, so you've got the name of the salt right, Laurie, but what else would be made? Well done, Amira.
Okay, I'm going to bounce
Well done, Margaret.
So we've got zinc sulfate and hydrogen, because it was a metal and an acid. And I'm going to be mean now. I'm going to skip lead and hydrochloric acid because I think you've got the chlorides sorted. So next one, a bit trickier, potassium carbonate plus nitric acid.
And we want all 3 products. So there's 3 things made, you can see there. We want the name of the salt and the other 2 products that will be made. Some good answers coming in, some correct answers.
Woohoo! That's what I like to hear, sir.
So Laurie, you've given me the name of what looks like a salt. Okay, remember, salts are always metal, non-metal. So the first part of the name of the salt should be the name of a metal. Have a look in there. Can you spot any metals? And then the second part should be a non-metal ion, which comes from the acid. And also, Laurie, I'd like you to give me the other 2 parts as well.
Bonus question for those who are done. What type of substance is a salt? From what Sir was just saying about a metal and a non-metal.
Oh.
Oh.
What kind of bonding would it have, I think, yeah.
Yeah. Did they get that one?
Some people are answering number 3, which we skipped, so but they got it right. Nobody has given me the correct type of bonding yet for salts, given that they are a mixture of metals and non-metals.
Oh.
Yep, that's correct. Some people answering number 3.
Oh.
Well done, Tally's answer number 3. Well done, Tally. That's right, but we didn't ask you to do it, but well done anyway. Salts are a non-metal. No, they're not non-metals. They are compounds. And what kind of bonding have they got in them? That's what we're interested in.
Metal plus non-metal.
Freya and Margaret and Kaya and a couple of anonymous people giving me the right answer.
Woo. Okay, so several answers for me to go through there. I'm going to wiggle through them. So for those who did number 3, lead plus hydrochloric acid is lead chloride plus hydrogen. And then the trickier one with the 3 answers, potassium carbonate plus nitric acid is going to make potassium, the metal, with nitrate to make the salt, plus carbon dioxide, because we've got that carbonate bit, plus water. And then the bonus answer, we've got a metal and a non-metal, so that would be ionic bonding, going back to what we were doing before. Okay, now we've mixed it up a bit on the next one. Lead oxide plus what type of acid produces lead sulfate plus water? Oh. Sounded like you're throwing money around there, sir.
Just dropped my ring on my tiled kitchen floor. That's what made that noise.
It's quite a nice jangle. So lead oxide plus what type of acid will make lead sulfate plus water?
Lots and lots of right answers. Well done, Laurie. Well done, Margaret. Well done, Zach.
Awesome.
Both 2 Zachs. So lots of correct answers coming in. That's good.
So you should have got, hopefully, sulfuric acid from the sulfate. And my next one has got 2 gaps. Magnesium oxide plus which acid produces magnesium nitrate plus question mark? What are the 2 missing words? And I want you to type them in the correct order. So what's the acid and what's the other product? And then that'll be the last one we'll do. I'll leave the bottom one because many I can't see it.
Okay. Yep. Getting some right answers coming in.
Woo! Whoop whoop. Sorry. It's been a while since I've whoop whooped.
Freya, you're half right. You've got the name of the acid right, but the other bit's not quite there. Well done, Margaret. You've got it. So people are really good at identifying the acid.
Yep.
This one. Hopefully you found that easy, considering it's magnesium nitrate. So good job. Lots and lots of people got the right acid. Well done, Emmy. First time I've seen you commenting with your name on. Thank you very much. And you got it right as well. So good job.
So with this one, it's oxide. So that's your insoluble base plus your acid. And what do they always make? They make their neutral salt plus what?
Macy. Well done, Macy. Again, first time I've seen Macy commenting with the name on. And you got it right as well. So well done.
Hopefully that helped a bit there as well, sir.
Did
they get the second bit?
They are now. Many more people are getting the second bit right. Well done.
So if it's the oxide, the insoluble base, plus your acid, in this case nitric acid, it will then produce magnesium nitrate plus water. Okay, excellent. You will get to practice these more, by the way, guys, so don't feel that this is the only option. Oh, this one I just wanted to show you. I think I've got time, haven't I, sir? I can never remember.
Yep, about 6 minutes.
Okay, so nitric acid reacts with ammonium hydroxide. An equation for this, what is formed, I'm just going to show you this one. So we've got ammonium hydroxide plus nitric acid, and then that will produce, and hopefully you can all see this bit, ammonium nitrate plus, and then we've got the hydroxide there, so that tells us it's an alkali with the acid. So I'm actually going to ask you guys, what's it going to produce? So we've got ammonium nitrate plus.
Now, some of you may not have met ammonia before. Ammonia sometimes behaves like a metal. It forms a positive ion. It's one of the unusual covalently bonded things that can form a positive ion. So a little bit unusual, and we will be meeting ammonia and ammonium a bit more. Okay, so some people are asking, why are we talking about ammonium nitrate? Well, maybe that's one of the products that might get formed. So remember, when we're naming salts, we take the name of the positive ion and the ammonia hydroxide, that's going to be the ammonium, and we take the name of the non-metal from the acid. Is ammonia so there are nitrogen compounds in urine which can, under certain circumstances, create ammonia. Now, in fact, ammonia is produced in your body, and your body converts it into urea and then excretes it in your urine, so it can be converted back. There isn't ammonia in your urine, but you can make ammonia from the compounds that are in urine.
Okay, so I've skipped it on because I'm just aware of time. I did try and highlight the bits there. I realised that I can do that. I keep forgetting. So ammonium hydroxide plus nitric acid will make ammonium nitrate plus water. And just as a quick show, there's the state symbols again here. So we've got the AQs for dissolved in water, and then we've got the hydrogen, the liquid for water. Water is a liquid, not a dissolved in water, because you can't dissolve water in water. Okay, now I have put on these last few slides, but I'm not going to go through them. They are there for additional if you want that little bit of challenge, because one, I've run out of time, and two, they are sort of higher information. So this is just about ionic equations, and you've done about ions, so it shouldn't be too much. And we've talked about the H+ ion of an acid and the OH- of your alkalis. And then there is just some information about how we write out ionic equations on there. So that's going to be extra reading. And afterwards, I will just put in a little slide to label that as additional reading. Because I've not got that much time, I just want to show you the big question sheet that I've put in. So you can see there's different questions. I've done a little box here which has got some questions not related to this at all. So temperature changes, exothermic reaction, and then a little bit of biology to see what you can remember. And then the rest of the questions on here are all about salts and reactions. And then this last one here is optional, which is the salts or ionic compounds. How can you work out their formula? So that's to do with ionic bonding and ions. So that's a little bit trickier for you. With these sheets, feel free to print them off and write on them so you don't have to be on a screen all day. Feel free to turn them into little flashcards, one for each little box. Or if you don't want to do that and you like working on a computer, feel free to type it onto the sheets. But they are there for you to use as a sort of summary of what you have been learning about. So because I'm aware we're very short of time, obviously rewatch this if you need to. Complete your Google quiz. Make some flashcards. I'll separate that slide for you in a minute, and complete the question big sheet thing that I've just shown you. Because it's running out of time, thank you for coming. And do you have any questions before I have to close us off? I'm going to give it 2 minutes just in case there's any questions.
In that 2 minutes, I'm going to play you. Can I share my screen?
Yeah, go for it. Do you want me to stop sharing?
Yeah, you stop sharing your screen. I'm going to share mine because some of you may have been missing science songs, Mr. Collins. Some of you may have been very pleased there have been no science songs, but this is one of the better science songs.
All about that,
in my opinion. It is. It is all about the bass. It's a rip-off of the Meghan Trainor, all about the bass. But instead of bass as in the bass line, it's all about the bass as in acids and alkalis. So let's see, share.
Whoever asked, yes, the recorded webinar will be posted once it's uploaded to the YouTube channel.
Because you know I'm all about that bass, no acid. I'm all about that bass, no acid.
I'm loading.
So you should write a science song, apparently.
Oh, my internet is sad. I'm trying to.
All about that bass, no acid. I'm all about that bass, bass.
The buffering really makes it, I feel. All right, maybe this is not going to work. And maybe if you go and search all about that bass, B-A-S-E, no acid, as you can see up here, all about that bass.
Yeah, it's pretty clear. I ain't no science.
I'm sure we'll get a chance to play them in class as well. So